When people imagine faster-than-light travel, they often picture liberation, starships streaking across galaxies, messages sent in an instant, journeys that defy the clock. But in physics, going faster than light isn't just about speed. It's about sequence. It's about what comes before and what comes after, and whether that order still makes sense. Because if something could move faster than light, then in some reference frames, the effect of an action could appear before the cause. Not hypothetically, not metaphorically, mathematically. Let's say you send a message from point A to point B at a speed greater than light. From your point of view, the message leaves A, travels quickly, and arrives at B a little sooner than light would have. So far, so good. But now switch to a different observer, someone moving relative to you. According to the rules of special relativity, their clock isn't ticking like yours. Their measurement of time and their judgment of simultaneous don't match yours. In their frame, the message doesn't just arrive early, it arrives before it was sent. And that changes everything. To understand why this happens, we need to look deeper at a feature of Einstein's relativity, the relativity of simultaneity. This principle tells us that two events that appear simultaneous to one observer may not be simultaneous to another, if that second observer is moving. For example, imagine lightning strikes both ends of a train at exactly the same moment, as seen by someone standing on the platform. But to a person riding inside the train, the lightning at the front arrives before the lightning at the back. Both observers are correct. Neither is lying. Time isn't broken. It's just relative. Now extend that logic to signals. If you send a signal faster than light, the usual rules of sequence can flip. What was cause becomes effect. What was effect becomes cause. The arrow of time becomes subjective. It doesn't take much to build a paradox from this. You send a faster-than-light message. In one frame, it's received before it was sent. So the recipient sends a reply, also faster than light, back to you. And in your frame, you receive the reply before you ever sent the first message. Suddenly you're reacting to something that hasn't happened yet, or worse, deciding not to send the message at all because the reply told you not to. And if you don't send the message, how did the reply exist? This isn't science fiction. It's not speculation. It's what the math says will happen if faster-than-light communication is allowed within the structure of special relativity. Relativity isn't broken by FTL. It's simply too honest to ignore what FTL implies. When observers disagree on now, and messages can leap across time, cause and effect dissolve. And when that happens, the rules we live by, conservation, coherence, sequence, are no longer trustworthy. The universe is no longer a story. It becomes a loop, a contradiction, a collapse. And so, to avoid that collapse, the universe seems to do something subtle and absolute. It draws a line. And on that line, the speed of light. To see how this plays out, let's walk through a paradox, one that doesn't need a time machine or a wormhole. All it needs is faster than light communication. Imagine you have a device that can send signals instantaneously across space, not just quickly, instantly, more precisely, faster than light. You're on Earth. Your friend is on a planet light years away. You send a message, maybe just a simple pulse across space. It reaches him almost immediately, well before light from your last hello could have arrived. To you, it feels like you sent a message to the future. But now, flip the perspective. Your friend is in motion relative to you. According to special relativity, they experience time differently. In their frame, your message didn't go to the future, it went to their past. So they decide to reply. They send a faster-than-light message back, using the same kind of device. And now, from your frame, something strange happens. You receive the reply before you ever sent the original message. And suddenly, causality folds in on itself. You now have a response in hand to a question you haven't asked. A warning before a danger is created, an outcome before the event, effect before cause. It sounds subtle, but it's not. Because if you act on that information, if the reply convinces you not to send the original message, then the loop breaks. You didn't send the message, but you received the reply. The reply exists because of a cause that never occurred. The result is not just confusing, it's inconsistent. Reality becomes contradictory. This is how faster-than-light communication creates logical paradoxes not by exotic technology, but by warping the structure of time. And the more you push it, the worse it gets. Now take the same logic and scale it up. You've heard of the grandfather paradox? The idea that if you went back in time and prevented your own grandfather from meeting your grandmother, you'd erase your own existence? It's a time travel cliché, but you don't need a time machine to make it real. Just send messages fast enough, faster than light, and the same logic applies. You could send a signal to your past self. Warn yourself not to make a decision. Change your own timeline. Create a contradiction. You didn't do the thing you were warned about, but that warning only exists because you were going to do it. What started as a message becomes a logical loop, self-negating, self-creating, an echo with no source. And in physics, this is a problem, because physical laws don't just predict outcomes. They require consistency. They need a way to move forward through time without contradiction. When paradoxes like this appear, it's usually a sign not that the math is wrong, but that the scenario can't exist. Not because it's hard, but because it breaks the logic of the system. It's like trying to divide by zero. The symbols exist, but the result is meaningless. Faster than light communication leads to exactly that kind of breakdown. Not noise, not chaos, nonsense. So to preserve coherence, nature seems to do something profound. It doesn't just prefer the speed of light. It enforces it, not as a preference, but as a defense. Because once you allow information to outrun light, time stops unfolding, starts circling, undoing itself in whatever universe that creates. It's not this one. By now, it's tempting to imagine a loophole, a hidden path, some clever workaround that lets us cheat the speed limit without tearing logic apart. Maybe a new kind of particle, a hypothetical technology, some undiscovered law of nature that unlocks the universe. But physics has already looked hard. And every time we push on the boundary, it holds. No object with mass has ever been accelerated to the speed of light. No signal carrying usable information has ever been shown to move faster. No experiment, no equation, no natural observation has allowed anything at all, to cross that threshold. And the reason isn't just practical. It's structural. You see, the closer you get to light speed, the more energy you need. It's not in a linear way, in an exponential one. Double your speed, it takes more than double the energy. Triple it, even more. Approach the speed of light, and the energy requirement approaches infinity. It's not that nature won't let you go faster, it's that it would take everything to try, and still, it wouldn't be enough. The laws of motion, the principles of thermodynamics, the framework of quantum field theory, all of them bend toward this one rule. No signal, no object, no influence may outrun light. This isn't about preference, it's about preservation. Because if faster than light motion were allowed, even in a limited, controlled way, then the symmetry of physics would collapse. Laws that hold true in every frame would fall apart. Identical setups would produce different outcomes depending on who's watching. The principle of relativity, the foundation of modern physics, would fracture. So physics doesn't just fail to allow faster than light travel, it actively defends against it. Through math, through energy constraints, through space-time geometry itself. The same equations that describe black holes, atomic particles, expanding space, they all conspire to protect causality. And perhaps that's the deeper lesson. The universe doesn't just unfold in time, it remembers its order, it respects its own logic. Every law we know depends on a consistent sequence. First this, then that, cause, then effect, tension, then consequence. Once you let that fall apart, once you allow cause to arrive after its result, you're not just breaking physics, you're breaking meaning. And the universe seems unwilling to do that, so it builds a wall, not a solid one, not made of matter, but a wall made of limits, of delay, of protection. The speed of light isn't a speed, not really. It's a defense mechanism, a firewall between the possible and the paradox. It may be the one thing in nature that cannot be broken because everything else depends on it. So when physics says no to faster than light motion, it's not closing a door. It's keeping time itself from unraveling. Whenever we talk about limits, someone always brings up quantum physics, entangled particles, instant correlations, spooky action at a distance. Surely, if anything in the universe can ignore the speed of light, it must be this. Two particles, Born together, share a quantum link. Separate them. Across a room, a galaxy is still when you measure one. The other responds instantly. It feels like a secret handshake across the void. It feels like faster-than-light communication. But it's not. What entanglement gives us is a pattern, not a message. When you measure one particle, its partner's outcome is correlated. But you don't control what result you get. Can't choose a message to send. You're just rolling quantum dice in two places at once and getting matching numbers. There is no signal. No cause leaping across space. Just a shared history expressed in perfect symmetry. This is where the universe remains consistent. No matter how strange entanglement seems, it does not allow you to transmit usable information faster than light. The correlations only become visible after the results are compared, and that comparison requires classical communication. Light-speed communication. Physicists call this the no-signaling theorem. It's not a loophole, it's a wall. Even the most sophisticated quantum experiments, Bell tests, delayed choice entanglement, loophole-free measurements, agree. Entanglement doesn't break causality, it dances within it. And what about quantum teleportation? Surely that's a kind of instant travel, not quite. Quantum teleportation lets you transfer a quantum state from one place to another, but only if you also send a classical message. Again, light speed is required. Without that signal, the receiver has nothing. The state remains locked in uncertainty. Even here, the universe insists on a delay. The entanglement creates potential. But knowledge, the part you can use, moves at light speed or slower. And deeper still, inside the equations of quantum field theory, the speed of light reappears. Operators commute only outside each other's light cones. The spacetime structure remains intact. Even the math is cautious. This tells us something profound. Quantum physics doesn't undermine causality, it reinforces it, because even in its weirdest moments, the universe refuses to let you rearrange cause and effect. It gives you mystery, but never contradiction. That's the real wonder. Entanglement looks like a crack in the wall. But when we examine it closely, we find not a breach, but a pattern. A harmony so precise that it feels like magic, until we realize the spell never breaks the rules. So when people say quantum physics defies logic, they're wrong. It redefines logic, and it keeps the speed of light at the heart of that definition. The cosmos can be strange, it can be playful, but it is not careless. And that's why, even in the entangled heart of quantum space, faster-than-light communication remains a fantasy. Not because the universe is boring, but because the universe is self-consistent, and it guards that consistency at every scale. Let's imagine for a moment that faster-than-light motion were possible. No paradox, no causality collapse, no contradiction. Let's pretend nature simply lets it happen. A spacecraft that jumps ahead of its own light, a message that arrives before it's written, a cause that casually steps behind its own effect. What would that universe look like? It wouldn't look like science fiction. It wouldn't look like progress. It would look like nonsense. Because if information can travel backward in time, if effects can arrive before causes, then every rule that makes physics predictive would break. Couldn't rely on equations to forecast an outcome, because outcomes might already exist before their inputs. Energy conservation becomes slippery. Entropy loses its arrow. The whole language of the universe, defined by what leads and what follows, unravels. Its memory becomes untrustworthy. The future can speak to the past, and what you remember may never have actually happened. The present might mutate based on timelines that haven't even emerged. Reality becomes interactive, but not in a way we can model or trust. There's a reason our most powerful equations, Einstein's field equations, Maxwell's laws, the Schrödinger equation, all respect the light speed limit. They are tools for describing a universe that unfolds, one event at a time, along a thread of logic. Cut that thread and the fabric loses coherence. You could write laws, but those laws would twist, depending on who's asking and when. You could write stories, but no story would ever have a beginning, middle, and end. Every plot could rewrite itself. Every experiment could undermine its own setup. A signal sent to stop a bomb could arrive before the bomb was built, preventing the setup that created the signal in the first place. This is not a quirk, it's a collapse. And it isn't just the distant consequences that concern us, it's the everyday ones. the way you strike a match, the way your neurons fire in sequence, the way you live your life, assuming that tomorrow follows today, all of that relies on causality being consistent. You don't need relativity to feel it. You feel it when you regret something. You feel it when you plan. You feel it every time you ask what happened and mean what led to it. Causality is not a luxury of physics. It's the foundation of experience. So if faster-than-light motion were allowed, even in one sliver of the cosmos, it would ripple outward, breaking every timeline it touched. That's why nature draws the line so clearly. It's not a wall to imprison us. It's a scaffolding to hold reality upright. The speed of light is not just fast, it's just enough. Enough to connect, cause, and effect. Enough to keep the future silent. Enough to let time be trusted. We may dream of going faster, but in doing so, we would abandon the one thing that lets the universe make sense.